all have this thing.
This title right here.
Rational function.
Well, that is the unit, so yeah.
Well, no, this sentence, I feel like I've seen this sentence 1,000 times. And I know
Maybe you were dreaming about it.
I didn't actually know. But we saw a lot of things that you felt like.
It's true enough. Okay, let's go over your homeworks.
Were we supposed to submit it online and not actually back there?
Well, was there a place to submit it online? Nope. Then there you go.
Is Malcolm back there?
I don't know.
he's sleeping.
He was here this morning.
He left.
So, I mean, unless he's disappeared or died, he's there. I mean, I guess if he died, he would be there, just not his soul, I guess. One part of him would be there. All right, so 8-2. We did 2 through 16. Does that sound accurate? Did you hear me yelling at you? He did. That's a yes. That's a yes, folks. You heard it here first. Number 2 is 63 a squared b cubed c to the 4th. 4 is x times quantity x plus 2 times quantity x minus 2 times quantity x minus 8. 6 is, shut up.
What are we watching?
Well, we're not watching anything. I just turned the TV on now, so maybe my phone. That was weird. I don't even know what that was. That was terrifying. You know what we should do? This will throw Landon for a loop. It's just carrying her. It's okay. We should find a different channel to turn on when the TV comes on. There you go. Forge and Fire channel. Perfect. There you go. Great. Okay. Now, back to the math. Now we don't have to. Wow. Fire. Okay. Great. Number 6. 35a plus 9b cubed all over 42ab. 8 is, excuse me, 7c squared y squared minus 12dx all over 56c to the 4th d squared. Number 10 is 10y minus 77 all over y minus 3 times quantity y minus 9. 12 is 11a plus 40 all over 6 times quantity a plus 4 times quantity a minus 4. 14, 4x plus 2 all over 3x minus 2. 16, 3y plus 2x all over xy plus 4x. What questions do we have on that lesson? 12. 3, 6, 9, the monkey drank the wine. Let's see if the TV showed up yet. Yep, there it is. Great. Now you can look at yourselves. Did you just fix your hair? Because there you are. There she is. Don't worry, camera people. I'll flip it around later. Great. Number 12, you said.
Yes.
Bunch of losers. Okay. Oh, she's astonished. Why is she astonished? She knows she's a loser. Did you know that losing some things is good? Your sanity is not one of those things.
Or your life.
No, it's pretty good to lose your life. Yeah, that was what I was saying. That was the reference. Okay, what should we do?
Obviously not what I did.
Yeah, same.
Well, okay, so do we have another idea then?
Factor.
We should definitely factor.
Yeah.
Well, I did do that.
Good. What does the left one factor to?
A plus
What does the right one factor to?
6 times a plus 4. Yes, 4.
Now what? No, nothing cancels.
It's a negative.
Oh,
I've had to learn.
You have been pounding that one in. It's finally there. Good job. So proud.
Multiply each thing by each other. That is
That was very pitiful sounding.
certain.
Does that seem reasonable to everyone? You missed a historic event, Nathan.
Oh no.
We changed the channel.
Yeah, my mom was making sourdough, so I was sitting in the car for 10 minutes.
Nice. What, did you catch in a stretch and fold moment?
Yeah.
Yeah. Okay. What now?
So wait.
I love that idea. We should distribute.
Yeah.
How could we kill the ace? How would that be even possible? No, why not? Because that. Listen to your frenemy. She's got the sword of the spirit. Okay, so we've got 18a plus 12 minus 7a plus 28 all over this stuff.
And we don't distribute them.
Yeah, I wouldn't, because why would you waste your time on that? Now what?
Combine like 10.
Wow. 11a plus 40 over 6 times a plus 4 times a minus 4. Great. Who do we appreciate?
Yeah.
Papa John's. Okay. No, that's Arby's.
10.
Papa John's has the butter. Actually, it's probably margarine, but you know.
Whirl.
Whirl? What?
It's a fake butter.
It's a fake butter.
It's even more.
I can't believe it's not butter. What number did you say? 4? 10.
We don't even have a full.
We did do 4.
Yeah, I did.
On the next one, we don't have it.
Yeah.
All right. We're supposed to find the least common multiple of... Oh, just kidding. I guess. I'm trying to do 4 here. Number 10. 8 over y minus 3 plus 2y minus 5 over y squared minus 12y plus 27. Wow. I think factoring sounds like a great idea. Let's do that. What is that? 3. That looks good. Let's do this now. Man, this is fun, isn't it? What is that? Whatever it is, I don't know. My brain is broken. 72. Thank you. Wow. Now what? Sounds great. Let's do it. So much fun. See, I made up for it.
Now can we do 4?
No.
Can we do 16?
How would you do 4? Because that's your question. That's your real question, right?
Yes.
You would factor the first one, factor the second one, and write out all the factors. Circle it. Move on with your life. Yes, yes.
Did something wrong there. Yeah, got it. I wrote them down.
So you were thinking right.
Yes.
Good job. Good job. I think we should do the next lesson.
Yes, I agree.
We might go back to this one. We'll see. All right, now is when we need the television, right? Right.
See,
That's why we turned on the TV and watched dancing, question mark. I don't really know what was happening. It's very strange. It was because I don't know. It was weird. I don't know.
weird, probably stage drama.
Well, definitely staged drama. That's true enough. All right, what did we do? We did 8 through 22. 8, x equals 0. F of x equals -3. The domain, x can't be 0. So negative infinity, 0, all the things. Range, the y can't be -3. Excuse me.
Bless you.
Okay. I have made that joke, so I guess I can't say much. Anyway, number 10, x equals 1, and y, or f of x, equals 5. And the domain, x can't be 1, and the range, x can't be 5. Now for the pretty pictures.
Dun, dun, dun.
12 through 22. Does that seem accurate? Yes, good.
Correct.
This is, wow, she tried to break it.
My head
That's
is-
crazy. We should flip the camera around while I'm thinking about it,
camera.
because Landon will want to know. Inquiring minds want to know. She is either, hold your camera still. She is either in Utah or she is on her way back from Utah. Assuming that's where she was visiting her brothers at, because that's, as far as I know, where they are. So, you know. They go to Brigham Young.
I'm going. You're going.
Yep, got to get a recommendation. Okay. What? You already have that? You're good little people. Hello, machine. Thank you.
Mine didn't make me get a teacher recommendation because I'm homeschooled. Well, you have to do like person that you know recommendation, senior teacher, and then but since I'm homeschooled, I did.
I thought I was done with that scammer. She's back.
This person texted me at 3:33 a.m.
Number 12. 3:33 a.m. That's because they live in some other country. There's number 12 right there.
Good job.
Yeah, okay, fine. Number 14 is this one.
It looks ugly, but it's correct.
Okay, do better.
Graph paper or
Looks correct, but it's ugly.
Okay. And oh my gosh. I keep like half shaking it or something. I don't know I don't even know how I'm causing that to happen. It's very strange.
I think you're taking.
Ah!
My phone is going
You
nuts.
might have a fuzzy thing.
Well, no, because I can see it.
Lens?
No, because you can see it right now. Something in the interpolation is like, what is this? This is supposed to be blurry.
Even there, it's so little blurry.
It is. It's weird. I don't know what it's doing.
Me neither.
It says
It's fun.
Yeah. It's like, no, this is math. You're not supposed to have the answers. Number 18. I recently created a business page on Instagram, and currently, like, it only follows like 2 people, myself and a friend of mine, and so it keeps telling me that I shared a photo, and which is kind of funny, but you know. Number 20 is that guy. 22 is this one. Ooh. Ah. Sure.
all you have to do is put it in.
22 would be safe.
All you have to do is put it in a table. Here, y'all want to see the scamming conversation? I passive aggressively called her a scammer already, but oh look.
Passively aggressive.
Apparently she lost €6 in an affair. That's what she just told me. So.
I told her, the scammer, that they were probably in a polyamorous relationship.
That's funny. So she calls me handsome. I'm pretty sure I've had a scammer with this photo profile before, but I could be lying. They tend to use the same thing. She asked me where I am. I told her Texas. She's in France, which is like what her Facebook profile says, which is more than the other lady, because she says she lives in Amarillo, but her Facebook profile says she's in New York. She also the only picture she has is from an actress from the 90s. So I've told her repeatedly that she's an idiot and she won't leave. So, you know, we'll see what happens. And she's single, and I was like, okay, whatever. And she wants to continue the acquaintance, whatever, and she wants to tell her main objective, and I don't really know what that means. And which is what I told her. And she says she's French, whatever, and I said the same things. And then she asked me if I've ever talked to a woman here before, and then I was like, okay, are you trying to say we should have some sort of romantic relationships? No, I'm asking if you ever met women on social media before. I said, not really. I've dealt with some scammers, and this is the latest one we'll share together. I'll touch back with you later. That's what I was expecting, actually, because I've met men who initially made me believe they were really the men in the photo he sent me. It was after some time of communication that I learned who they actually were. So from then on, I'm suspicious of everything because I decided to lose 6,000 euros in this affair. But then I got in touch with the Interpol cell based in an African country, and they were the ones who helped me recover my money and arrest the people who were behind it. So if you've ever been in this situation, I can put you in touch with the anti-money laundering platform. Thank you, lady. Okay, let's do math.
Sounds like AI wrote that. What the heck?
Right?
It's like, here, let me type his answer in ChatGPT.
Right, exactly. Exactly.
How do I respond?
Type response.
I kind of think that that's what's going on with this other person. Either that or they have like disappearing messages only on their side because this other person I basically called a complete and utter moron on probably literally that, and because they were like the worst scam, like the stupidest scammer I've ever seen. And then I didn't delete the chat and whatever, which is what I normally do, but I didn't. I don't know, I got distracted or something, who knows. And then they came back and tried to start the same conversation with me. Did you not go back and read the previous conversation? Because the last thing that happened was I called you an idiot. So I don't know why you're trying again. Good to go. Number 22. Big babies.
No, we're little babies. There's a difference.
Malcolm, you weren't anything but little, bro. Bless you.
Thank you. I like your man bun, Sean.
Well, thank you. It's just a bun, but whatever.
I heard that, and I was like, what?
No, that was on the challenge. Okay. So, what should we do?
Get rid of that multiplication on the.
Yeah, I think that's a great idea. Clean it up a little.
Multiply by 4. Only on the fraction, not on the separate 2. Just completely separate.
I was trying to decide whether to listen to you or not, but I think I'm not going to listen to you.
What?
But does it work if we do it the other way?
Yeah, maybe. Look, now it looks like something we know how to deal with.
Is that 1/2?
It is 1/2. Why is it 1/2? What did I do?
Wait, why did you put multiply by 4 by that? Shouldn't it be multiplied by 1/4 times the?
Oh, yeah, you're right.
And
Oh.
1/2 would be 8.
Which would make this like totally different, wouldn't it? And then, yeah, it would be 8. -8. You're right. Which would make this -20.
Yes.
Does that bottom one still be 1/2?
No. Okay, so now back to my previous question. Why is it that? What did I do?
You just did usual fraction stuff.
Multiplied it? I mean, adding them.
I did ultimately the same thing y'all are saying to do. I just did it like Algebra 2.
Yeah.
I factored out a 1/4,
Yeah.
right?
Is that not what we're supposed to do?
You said multiply by 4, right? That was what came out of your mouth and her mouth, right?
Well, yeah, multiply the whole.
So another way to do this, by the way, in case we are curious, would be to do this.
Yeah.
Yeah,
That's what I did.
great. Did you end up with that? Good. We're all happy. When you factor out a number, what do you do with that number on all the terms? You divide it. That's what we mean by take it out. 2 divided by 1/4 is 8. That's why that's 8. That way.
Yes.
Okay, great. Happy days are here again. Now what?
Now we put a graph up.
Nah, I don't like to do that next.
Parent function.
Sure, parent function. Great. Now what?
Oh, find the asymptote.
I like to figure out how it's transformed, right? That's what I like to do. So how is it in fact transformed?
Right 8 up to.
Right 8 up to reflected stretched by 20.
Which is a big number.
Great. Then, yeah, it is a big number, which means I probably don't want to count by ones.
Probably either like 2.
It's a be real.
Real.
I would do 4 because I mean 20 is
Does anybody in this room not have Be Real but have other social media? Well, that makes sense. That's fine. I was just curious because that would be a weird rule. Like I have allowed my child to get Be Real because Be Real is like the most not offensive. No, I'm gonna take your phone away. You can do that in public school. In fact, you do that in public school.
You can't do that. I'm not in public.
Oh, I can't do that. I have definitely taken students' phones away, but I have not charged them $20 to get it back or whatever happens at a lot of public schools. But yeah, I have definitely taken students' phones away, but that's mostly in like Algebra 1.
when they're being rowdy and stupid.
No, why? Because they're just sitting there on their cell phones.
Yeah, which is stupid.
Which is under
All right, what do we want to count by?
Force.
Sure, why not? 1, 2, 3, 4, 5. Actually, before we decide what we want to count by, we should like make a table. See what kind of numbers we're dealing with. How does that sound?
Sounds like good.
Okay. What numbers do we want to put in there? Huh? 8? Why would we put in 8?
A 2.
8 would be a giant mistake.
A 2.
a -1.
Guys, y'all are in Algebra 2. You are smart enough to have a clue what numbers. We're not back in pre-algebra and Algebra 1 where you would just throw out random crap.
I know, 28.
No.
Wait, what?
What do our numbers want to circle around? Which asymptote? That's the up and down one. Around the 8. So what numbers do we want to put in?
6.
7, 5, 4, 3, 2.
How about that? This is a good place to start.
Yes.
And then if we decide we need 28 for some reason, then sure.
I mean, it would be 28 minus.
Yeah, it'd be a 1, yeah. Yeah, I follow you. I follow you.
No.
But you weren't following me. You were having too much of a clue. We need a little clue.
Plug it in.
Okay, plug it in. Great.
2, and then it'd be 10, and then it'd be 12.
Do we actually even need to finish this problem, or did whoever was asking about it understand what's happening at this point?
Yeah.
We still need it? Yes? It's fine. The answer is yes. Yes? Right? No? Yes? Who knows? Oh my gosh, bunch of crazy people. -2 plus 2. -20. What?
10.
Yeah, 10 plus 2 is 12. Great. F of 7. 7's a stupid number. Let's pick even numbers.
Yeah, I realized that. I was like,
Well, 7 minus 8 is -1.
yeah, and then it makes it a gross 22.
Oh, that's true. It is. It would have been fine. Even numbers. 4 minus 8. -4 plus 2. +5 plus 2 is 7.
Say that again.
Got replaced by 7.
+5 plus 2 is 7.
Yes.
True?
Not a good number.
What's wrong with 7?
7 is fine.
No, I'm thinking about the next one. So.
12 is not a good number? What's 12 minus 8?
Makes it
12 minus 8 is 4. 20 divided by
5, but
-5.
-3.
they're like negative.
I don't like well, you're in the wrong class, girly. I think you're just trying to cover your mistake. Don't worry, I made 100 today. Geometry was like nonsense. I looked like an idiot in geometry.
X is -8.
10 minus 8 is 2 plus 2. So -10 plus 2, -8. Let's graph it.
Yeah, let's graph it.
Let's count by 2s. Why not?
You said 4s.
No, y'all said 4s. And then I said, let's see what we need to do. 6, 12. So 1, 2, 4, 6, 8, 10, 12. There-ish. Oh, what did I not do that would be helpful to do? Asymptotes. You don't have to sound so depressed about it. Calm down. You want to know something I'm tired of?
Why?
I'm going to tell you. No, I'm not tired of life. Life's fine. Life's great. That's like such a Gen Z answer.
Phew. I was worried.
Oh my gosh. No, I'm not tired of life.
Tired of you.
I am a little tired of Gen Z people saying, oh my gosh, I'm tired of life. But I'm also tired of teenagers complaining that they're tired.
I'm tired.
They don't even understand. Teenagers don't even know what tired means. 4, 7. Wait, something's clearly not right.
Nah.
Clearly there's a mistake in there somewhere.
Is it negative, just like up here?
Yeah, that's supposed
So
to
it
be.
should be.
Oh, I know what no, wait. Oh, I know what I did wrong. What did I do wrong?
Probably some math somewhere.
No, it was not any math. There was no math that was mistaken on this particular problem. It's not the math.
Wrong.
What? I did what?
Oh yeah, you swapped the asymptote.
Yeah, I did. Yeah, I put the wrong asymptote in the wrong place. Dots are great. The asymptotes, I somehow put their inverse for some reason.
Inverse.
Inversed asymptotes. This.
Asymptotes.
Try again. How about this one is her.
Sure, Sean. That sounds like a great idea.
What is even that?
Rethink.
I don't understand that video. Y'all know what I'm talking about?
No.
I don't even understand like the context or why it exists, or it's just a really stupid video. I don't even get it.
Which one?
I don't get why it happens. 6, 8.
What are you talking about?
I'm talking about the video where the guy is mad at the weirdos and he says, what the heck is even that? I don't understand that. It is very stupid. 2, 4, 6, 8, 10, 12, negative 2, 3, 10, negative 2, 4, 6, 8, and then connect the dots. It's perfect.
Connect the vowels. What? Why did I say that?
Connect the vowels with consonants, unless you happen to be Irish, or more like Icelandic.
Denmarkian.
No. Well, pretty sure the word cairn is Irish, but you know, that's about as good as I can get. And that's got lots of vowels, so you know, bad example. Great. Anyway, any other questions?
No.
Let's learn some more math. Graphing rational functions. Speaking of Papa John's, you've earned Papa Dough. All right. Okay, so a rational function is a function in this form. A dx and b dx are polynomials. What is a polynomial? We know this by now. Yes, what does that mean? Terms. It's the word you were looking for, but yes. Yes, it does have multiple of those. There are a possibility of 3 different kinds of asymptotes on a problem like this. So, if the degree, what does degree mean in context? No.
Oh, that's right, the highest value.
What's the degree of that polynomial? 4. Great. Thank you. Great. Great, great, great. If the degree of a of x is greater than the degree of b of x, then there is no horizontal asymptote. Which would look like something like this. We have f of, this is simple example without much instruction, just a demonstration. Something like this. The degree of the top is greater than the degree of the bottom. Now this one actually has a specific kind of asymptote, which we'll talk about in a minute, because it is specifically one more than the bottom. And it will look something like this. Don't worry, you'll understand how to put this in a place later.
So like the first little example on this page.
It'll look something like that.
There's no horizontal?
There's no horizontal asymptote.
Going.
Flat asymptote, right? There is a vertical asymptote on this particular one. It's right here. Okay?
So there's just like a big space between?
There is a big space between, but not an asymptote.
Nothing in there?
There's nothing in there, no graph in there.
That is funky.
That is funky. Next option
I like that. This is cool. This is interesting. Math is fun.
if the degree of a of x is less than the degree of b of x, then the horizontal asymptote is at y equals 0. So something like this. F of x equals 3 over x squared minus 1. Before I draw this example, what makes this particular one different than a reciprocal function like the one we learned about in the last lesson? What is different about this? No, not the 3. The 3 is just like what we talked about before. That 3 is the a, yeah? The squared in the denominator makes this look different. This does have a horizontal asymptote, which in this particular example, only 2 parts of the graph care about its asymptote. Again, I'm not going to draw numbers on here, and I'm not going to draw anything specific. You're going to learn how to do all of this and figure out all of these things exist. But we don't care. We're just looking at what a horizontal asymptote would be like. What is the degree of the numerator on this particular graph? The numerator. The degree of the denominator is 2, and no, it's not 1. It's 0. it has a horizontal asymptote where this part of the graph gets closer and closer to the x-axis, never gets there. This part of the graph gets closer and closer to the x-axis, never gets there. The limit as x approaches negative infinity is 0. The limit as x approaches is positive infinity is 0. Y'all don't have to think about that. What?
That's a sad looking face.
It's not a sad looking face. That's false. It's a function that has this equation. Third option. Third option is, what do y'all think the third option is without cheating and looking at the book? We've already had greater than, we've already had less than. What's the third option? If it's equal, great. If the degree of a of x is equal to the degree of b of x, then it also has a horizontal asymptote at y equals the leading coefficient of a of x over the leading coefficient of b of x. So something like f of x equals 2x plus 1 over, that's just x, yep, I was not lying, x minus 3. What's the degree of the numerator?
1.
1. What's the degree of the denominator? 1. They match. Great. So what is the leading coefficient of the numerator?
2.
2. What is the leading coefficient of the denominator?
1.
What's 2 divided by 1? 2. What makes this function different from the last lesson? What does it have that last lesson's examples didn't have? It has x in the top, as well as the denominator. Great. Let's graph kind of what he looks like.
This is weird. I like this. I can relate.
You're so excited about it, you're repeating yourself at this point.
Yes.
So this would have a horizontal asymptote at y equals 2.
This looks like the ones that we did already, though.
It does kind of look like the ones we did already, this particular example. They don't always. We haven't even talked about vertical asymptotes or oblique asymptotes.
Why is this one making an X?
Where would... Okay, let me ask you this, boys and ladies. Where... It's right. Where would the vertical asymptote on this be? Don't look at the book. Don't cheat.
I've already looked though.
I'll try to think through
I don't
why
know.
it would be.
What? That's good. Way to go. That's exactly what you should be thinking. What would cause a vertical asymptote? The 3. So what could it not be?
0. Or
The denominator can't be 0, which means x can't be 3, because 3 minus 3 is 0. So, as an asymptote, here-ish. So yeah, this one, this particular one, looks a lot like a reciprocal function. In fact, if we were in a real life situation and we were trying to model some data using this, we would have to make a educated decision on whether to use this form or whether to use the other form.
What data looks like?
We don't care.
But I do.
Well, good. Go look it up on your own time. We don't have enough time to go into those things. Well, that's fine. Then you don't care that much, do you? Okay. More things. So we just kind of talked about how to find the vertical asymptote on a rational function. How do you find vertical asymptotes on a rational function? They always have at least one, always. Because the degree of the denominator will never be 0. It'll always be 1 or greater, right? Or else it's just like linear, exponential, or whatever, right? So how do we find the vertical asymptotes?
Good question.
We do it by setting b of x equal to 0. Because b of x cannot equal 0. So to find the vertical asymptote or totes, we set b of x equal to 0 and figure out what we get. Easy peasy? Now, there is, and I have alluded to it about 4 times if we count Tuesday, there is a third kind of asymptote. It is called an oblique or slant asymptote. So not vertical, not horizontal, some other thing. You know, I keep putting 2 S's in there, but I think the word only has 1. It's more fun to put it with 2, but I don't think that's how it works. I don't think I have to explain. I think your tone understands. If, we know it has one if the degree of a of x is 1 more than 1 greater than the degree, of b of x. You know, I haven't checked the video in a while. Is it still working? I keep forgetting to do that, and then something happens halfway through, and then people are like, oh my gosh, I was confused. I didn't know things.
Yeah, that's what people say.
That's what me and Lizzie say.
Well,
Lots of people say that.
I didn't say all people.
But I did.
That was a dumb joke, bro. You gotta work on that. So, it is. It's right there, and it's also slanted. Wow, connections. Okay, so something like f of x equals, they use x to the 4th. Yeah. X to the 4th plus, what time is it? Yeah. We are going to shake up the order quite a bit. 3x cubed over x cubed minus 1. Okay. This one we are going to work as a full example. Okay. So, does it have a horizontal asymptote? Yes or no?
Yeah, yes.
How do we know whether it has a horizontal asymptote? What's the degree of the numerator?
Less than the degree, or more than the degree.
What is the degree of the numerator?
4.
4. What is the degree of the denominator?
3.
Therefore, the degree of the numerator is greater than the degree of the denominator. So what does that tell us about horizontal asymptotes? There's not one. Now, it's also just one more, so it does in fact have an oblique asymptote. Great. Now we got to figure out what that is. But just for grins and giggles, let's do this part. How do we find the vertical asymptote? X cubed minus 1 equals 0. And then we solve for x. How do we do that? You mean the cube root, but we don't want to do that yet. We do add 1 to the other side.
And then do the cube root.
And then the cube root. Now, we have to ask ourselves a question at this very moment. When we take the cube root of both sides, do we end up with plus and minus? Yes or no? No. Why not? Because it's not even. Look at you remembering stuff. Wow. So impressed. Breastplate of righteousness it is. So x equals not plus or minus, but just straight up 1. So there's a vertical asymptote at x equals 1. Great, we did a thing. Wonderful. Now, we need to figure out what the what the oblique asymptote is. Okay? So, what we do to figure that out is we divide the numerator by the denominator. We will get a line as our answer. That line is where the horizontal asymptote is. So, how do we divide the numerator by the denominator? We put the denominator on the porch, numerator in the house, and then we start dividing. What is my next step? Yeah, and we have to do long division because that's a 3 and not a 1. If it was a 1, we could use synthetic division, but it's not. What do we do?
See how many times 1 gets into,
No, but you're on the right track, but you use x cubed. X cubed goes into x to the 4th how many times? X times. Now what do we do? We distribute. X times x cubed is x to the 4th, which matches this one, which is great, because that's what we want, because we want it to cancel, right? X times negative 1 is what? Negative x. Great. Now what do we do?
subtract both of them.
Subtract. How do we subtract? Flip the signs. Great. Okay, so this becomes minus, this becomes plus. X to the 4th minus x to the 4th cancels. Does this, can we combine these? No. 3x cubed plus x. Now what do we do?
Now we get the next one.
X cubed goes into 3x cubed how many times? 3 times. Now what do we do?
Now we multiply those things.
Yeah, we distribute. 3 times x cubed is 3x cubed. It matches. Good job. 3 times negative 1 is negative 3. Subtract. That cancels. How many times does x cubed go into x? None times.
Zero.
None times.
Get the remainder.
So we actually have a remainder. So, what is the equation of our oblique asymptote?
That.
We don't care.
What?
What do you mean?
If you do one of these on your homework, it won't have a remainder. And if it does, we don't care. Let's graph it. What? Because all we care about is where this is. I feel like it also repeats or something. I don't know. That's something else. All right, let's graph it. So, what are we going to put on our graph? Our asymptotes. Where are they? There's one right here. And there's a slanted one. We go up 1, 2, 3. Then up 1 over 1. And beautiful. Great. Now what do we need to do? Get some points.
Get some points.
Yeah. So, what point should we pick?
We should pick ones that'll be in the little triangle.
Not 1.
Not 1. We should pick ones to the left of 1, to the right of 1, right?
2.
What?
3.
How about we put,
2, -2.
what am I doing? How about -1, 0, 2, 3. Look, I did it in order.
Okay.
I was scared for a moment. 1, 2, 3.
What is -1 to the 4th?
Makes it even.
1.
Yeah, 1 minus 3 over -1 minus 1. What's -2 divided by -2? 1. We like 0. It equals 0. If this is 0 plus 0 and that's 0, as long as the denominator's not 0, it's 0.
Wait, why can't you divide 0 by 0?
You cannot. Unless you're in calculus and then you like get infinity and stuff, but you know, that's a different context. Okay, so let's put a 2 in there. Two squared is what?
2 squared is 4.
It is, but what's 2 to the 4th?
2 to the 4th. Oh, 2 to the 4th is 16.
16 plus 2 cubed
8.
times 3.
24.
8 minus 1 is 7. This is going to be an ugly number.
42 over 7.
It's not 42.
It's not 42.
40 over 7.
40 over 7. Oh,
What is that less ugly?
well, that's just like
7 goes into 40 how many times?
35.
35. So 5 and 5/7.
yeah, that's ugly as sin.
It's not that ugly. It's fine. Okay, let's put a 3 in there. F of 3. It's going to be some crazy number. And then you're going to graph it, and it's going to look like this, right?
What's 9 squared?
It's going to look like this. Right? Homework. Page. $5.58. Numbers. Oh, perfect. Perfect.
Please give us only 2 questions.
8 through 26 evens. It's due on Tuesday.
So do it on Tuesday.
No,
No.
no. Don't do it on Tuesday.
Do on Tuesday. Do
Start it tomorrow.
Or today.
or today.
That's fine. Today is fine.
Today's
Nah.
a good day.
Do it while it's fresh and pump out some brain power, and then finish it later. And then you'll be surprised to discover that you actually understand better.